Hi everybody. I'd like to present for your consideration some code which is used to check a string for properties. Here we have a string which has an uppercase character, D, and we would expect hasUpper to return true. When we run the code, we can see that the true is certainly returned right in here. Here we see lowercase, and that returns false because it has no uppercase character. Here we see has defined characters, and the answer is false because it has no undefined characters. Here we have has undefined characters, returns false because it has no undefined characters. Here's has digits, returns true because we found some digits. So to make this work, we write a program, a little procedure that iterates through the string. The string is passed in as a parameter. We look at the total length of the string, we determine what the character is at each position of the string, and we run it through isDigit. A little flag returns true if we find some digits, and then we break out of the loop and return the flag. So we start off with the flag as false, scan through the digits, and return true as soon as we are satisfied with the condition. Take the same exact code, duplicate it. Now do the same exact thing with a difference, and the difference is you change the predicate and you determine if a character is defined or not. And if you're looking for undefined characters, then you say not defined, and then you do the same exact thing. Take the code, duplicate it. Duplicated code is what they call in refactoring a bad smell. Right? This is very typical kind of code. It's very simple code, but it's being duplicated all over the place. Everything is working the same with the exception of the predicate. And it says, is this uppercase? And if it's an uppercase character, we return true. And now we see, wait a minute, this code looks just like that code and even has the same predicate with a difference. And the difference is now, instead of running with a string, it runs with a string buffer. Different reference data types. Strings in Java are immutable. They cannot be created. They can only be overwritten. String buffers are far more efficient. So if you're doing efficient string processing, you don't want to convert to string, and you don't want to convert away from string. You just want to stick to string buffers. So now all of a sudden, you have to rewrite all of that code that you just saw, only with string buffers. And you say, well, wait a minute. What if I'm not doing string buffers? What if I'm doing an array of char? Well, then you have to rewrite the whole thing again with an array of char. Granted, a string can be converted into an array of char, and then the array of char can be converted back to a string, but wouldn't it be better to just stick to an array of char? Unfortunately, it means having to duplicate all the code, and now you've got to do hasUpper 3 times, and then you have to do the same thing with hasDigits 3 times. And you've got to do the same thing with all of the other predicates. That keeps multiplying, and the amount of duplicated code keeps increasing, and the maintenance costs keep going up. This is not a correct way to do object-oriented design. Yet, it's very common. So what do? Well, the answer is we come up with the strategy pattern, which allows us to reuse a whole series of different predicates for the single purpose of being able to satisfy some simple interface. So we create this really simple interface, right? And in my view, the best interfaces are the simplest. And here is one. It just says, look, if you got a character and you accept it, you return true. And that's it. Using this simple character filter, I can remove a whole ton of different code. Now, when I go into my character utilities, I can look at the filters, and I can see, aha, these are very simple to implement. Here is what we have, an anonymous inner class. The anonymous inner class gives us a class which is uniquely defined because it has an implementation for the accept function, or accept method, which is different from all the others. And so what happens is we create, through the process of name mangling inside of the compiler, a class which has a slight difference from each other class. The accept function returns isUppercase. Here the accept function returns isDigit. Now we can see, aha, that's a digit filter. If it's a digit, it returns true. An alphabetic filter returns it must be alphabetic or it's undefined. We could call this the undefined filter if we like. Here's the white space filter, the currency filter, which looks for currency symbols. If it finds one, it returns true. And now, when we start to use it, we just use the simple code, contains characters. We can pass in the upper filter. Here it contains characters. We can use the upper filter on this lowercase string. And similarly, we can look for digits using the digit filter. Now, if you want to, let's convert 1, 2, 3 into a character array. Turns out the same character array can be used with the digit filter as the string because of overloading, right? So if you look at contains characters 1, 2, 3, where is it defined? And the answer is right in here. It takes a string and a character filter, and now it proceeds to use the accept method, which has been defined for us in this character filter. So we only need one of these methods to go through and scan because we're reusing the character filter. Moreover, if you went back to that code which is using this character array, and you say, well, geez, which one is this using? It's overloaded. So it automatically dispatches at compile time to the contains character, which does not take a string, but instead takes an array of char, which is great because what that means is we're going to use the very efficient scanning facility and reuse the filter. So we choose whichever algorithm unifies with the overloaded parameters. In a sense, we're using the strategy design pattern again. Let's see how that might work for a string buffer. Suppose I start with a string buffer, SB, equals new string buffer. And that string buffer is given an argument which contains a literal string. This is a test. Upper. And now, if we want to see if something contains a uppercase character, we can say contains character. And now we can put in the string buffer. And now we can use the upper filter. What that means to me is that when you go to see how this is dispatched, it automatically dispatches to the string buffer. And now we proceed to scan through the string buffer, which uses rather different arguments than, let's say, a character array. So one of the things that I think is really interesting about this approach is that we can have efficiency, we can reduce the total number of lines of code that we need, and we can also reduce our maintenance costs. Because remember, in software engineering, the mantra is 80% of the cost of a software engineering project is in maintenance. And if you have a lot less code to maintain, this should make maintenance a lot cheaper. And that is how you do the strategy pattern.